Huh? Sure. I mean, none of your faces are in the frame, so it doesn't really matter. So I'm gonna change that. Could change it. So hey everybody, welcome to Intro to Unity, Rocket League-ish edition. Normally when we run these workshops, we pick a more boring tutorial like Roll-a-Ball, where you roll a ball and you pick up points. You're gonna learn a lot of the same concepts from Roll-a-Ball, but it's just a little more interesting. I tried to package it up in something that's a tiny bit more exciting. Just by show of hands, has anyone touched Unity before? Like, have you ever opened it, done anything before? Okay, cool. That's okay. How many people have, like, scripting experience, like coding experience? Cool. Okay, so just a disclaimer, the code I'm gonna show you here, I'm sure it breaks every best practice ever, but it's good enough, so we're not gonna worry about that. Like, I'm just concerned about super basic 101, let's function in Unity.
We gotta point out every little thing.
If you want to, go for it. So yeah, and I think I failed to introduce myself, although I'm sure you picked up who I am. My name's Justin, I'm part of the game developers, and I'm gonna be the instructor, I guess, today. So, and just to give you a quick idea of stuff I've done in the past, there's a bunch of stuff. Most of those are game jam projects. Funnels and Fizzlers was a Portal 2 map that I made for a contest like way back in 2011. Moving Simulator was for one game a month, which is where you make one game in a month. Those are both solo projects. Everything else was a game jam project, which was very much a team effort. They're lots of fun, and the reason I highlighted Nebula Strike is because we didn't finish it, but it was still a lot of fun. So, and there's some screenshots. So like in the upper left-hand corner is Kung Fu Shadow Fist, which is a VR title that Digital Precept is working on, which is, ask that guy right there, he'll tell you all about it. The upper right-hand corner, that's a screenshot from Witching Hour, which was one of my latest game jam projects. It's kind of like sound management gameplay, I guess is the best way to describe it. Basically, like, you have appliances that are like possessed, and you have to go and turn them off because they keep turning themselves on, and if they make too much racket, this ghost will spawn in and just scare you. The bottom left-hand corner is that Portal 2 map I mentioned, and the bottom right-hand corner, that's my first game jam project that I participated in. That's a game called Intrigue, where the theme was enemies or weapons. So you can't affect your target directly, but you can indirectly. So you can like plant like contraband on them, or like get somebody else to do the dirty work for you, that kind of thing. So yeah, that's kind of been my journey with the Memphis Game Dev so far. But let's get back to a little more relevant stuff. So today, hopefully, I'm going to teach you about just kind of like the general Unity interface, how to successfully kind of navigate around Unity and kind of work in it competently. We're going to learn a little bit about the asset store and why you should rely on it. When I first started messing around with Unity, I had this aversion to the asset store for some reason. I wanted to make everything from scratch. That's really dumb. Don't do that. We're going to cover some really basic game dev terminology. We're going to talk about Unity primitives, which are just like basic 3D shapes. We're going to talk a little bit about scripting. Again, that's highlighted because everything I'm going to show you from a scripting perspective is probably wrong, but it'll function. So don't worry about it. We're going to touch on Unity's built-in physics engine a little bit. We're going to talk about some of the triggers and how you can trigger events and things of that nature. And we're going to touch on the UI system very briefly. So we're not going to do a deep dive into any of these, but we're going to just do like a broad overview, and you should get the picture pretty quickly. I included this slide as a joke, but I thought it was really important to keep because it illustrates, I'm trying to collect my thoughts here. So you're one person. You're never going to be able to make a AAA title. I don't care how hard you try. You're just not going to be able to do it, especially at a game jam. Like if you go to a game jam or you start your own personal project, the scope creep is it's gonna be real. So from a game dev perspective, I feel like it's really important to take your core idea and break it down into like the simplest concepts and build on those, execute on those. So you can see the bottom screenshot. It's really boring, but it's what we're going for today. It's simple. It'll teach you some basic Unity, and yeah, that should work. These are our requirements for today. I also wrote them on the board. Too long didn't read. We have a car. We're cheating here. We're going to use the standard assets car. The standard assets are really useful when you're prototyping a game. You could rapidly prototype something and just throw things in a scene and kind of get an idea of where your gameplay is headed. We're going to have a camera. It follows the car, and it has two modes. You have a car cam, which focuses on the car, and you have the ball cam, which focuses on the ball. We have the ball itself. It just rolls around. We have our scoring system, which is just going to be a very simple counter. It'll display that score to the screen, and when you score a point, it will reset the ball to the middle position in the field. And then we have a level. It has goals, and it just contains everything that we in 1 through 4. It might look good. More than likely it won't, because I've got an hour and I'm one guy. But yeah, that's kind of what we're going for today. And I'll touch on this when we're done, but Unity has they're a great resource for tutorials. They have everything ranging from super basic all the way up to like networked multiplayer, which is witchcraft. Yeah. Participate in game jams if you can. Those are great places to learn and just kind of sharpen your skills a little bit. They're a great exercise in time management. Work on your own ideas. What'd you say? Oh, there is one next weekend. I forgot. It'll be here. I'll talk about that later. But yeah, we have a game jam coming up. Work on your own ideas. If you have an idea for a game or like a subsystem in a game, just go ahead and just play with Unity. Also, attend local meetups. Wink, wink. So that said, let's go ahead and open up Unity. So like I said, we are going to use the standard assets. Does everybody have that? Do you know if you have the standard assets? Just show of hands. Okay, I think we're good. Here, I'll get rid of that. Okay. So I'm just going to go ahead and spin up a brand new Unity project. If you've never touched Unity before, you get this nifty little launcher. To open up a new project, just click New. Name it whatever you want. Be sure it is a 3D project. Let's call this one Live. And I think you can add an asset package from here. Yes, this is everything I have, I think. Yeah, so if you go to Asset Package, just scroll down until you see Standard Assets, and that should just include that in your project by default when you open it up. Click Done, and Create Project. And Unity will do its thing. I'm also recording in the background, so this might take a tiny bit longer than it really would otherwise. There it goes. Sorry, I was getting a little worried there. I hadn't practiced like actually opening up that assets pack while recording, so I didn't know how long that was going to take. So while this is doing its thing, again, I just want to reiterate, it's always useful to keep a list of what you're trying to work on. And if you can break an idea down into something that's simpler, always do that, because it's always easier to work on smaller tasks. The car is going to be pretty straightforward. If Unity ever decides to open, there is a car prefab. It's effectively a car controller where you can just dump it into a scene, and it'll we'll drive around with W, A, S, and D, and that's a lot of the dirty work there already done for us. So like I said, it allows you to prototype very rapidly, which is pretty sweet. Does anyone have any questions while we're waiting? Again, I apologize about this.
I just got here.
Uh-huh.
What have you guys been discussing so far?
So far, I've only really given a brief overview of what we're going to cover. You haven't really missed a whole lot. We haven't covered anything super important yet.
Okay, good.
So,
Can you tell us more about this upcoming game jam?
yeah, so the upcoming game jam is Ludum Dare 41, I believe. So the idea, has anyone ever attended a hackathon before? Okay, so a hackathon and a game jam are very similar in that you get a pretty restricted time frame to work on a project. Ludum Dare is, I believe, 3 days?
Friday through Sunday.
So 72 hours? Yeah, so Ludum Dare, you get 3 days to actually work and build a game. And at the end of that weekend, you just kind of like turn in what you have. Does Ludum Dare have a contest?
There's a competition, and then there's also a casual.
Yeah, but for the competitive one where you actually like can win things, you have to write everything from scratch, right?
Yeah.
That's what I thought. So we usually participate in the just the casual one because you don't want to write everything from scratch. Like they prohibit you from using like Unity or Unreal or any other game engine. You have to do everything from scratch, and no, don't do that. But yeah, they're a lot of fun because like even if you don't know anything, you can just show up and you can just tackle a thing for a weekend. Like if you don't know anything about 3D modeling, you can just like whip out Blender and Google and try and make 3D game assets. If you don't know anything about shaders, you can attempt that. I don't recommend it. Shaders are witchcraft, but if you want to, go for it. And they're just like great places to learn. Like you can shadow more experienced people and just kind of see how they work and just learn a whole lot. Good timing, Unity. Thank you, Stephen. Thank you. Okay. Does everybody have these two directories in their project? It's going to be the sample scenes and the standard assets. That'll be fine. Standard assets is fine.
I think you might have just moved sample scenes into standard.
Probably. I don't think it'll matter, though. The only thing that matters is if we have the standard assets. So it looks like we do. So if you want to follow along and kind of see how you want to mirror your screen to mine, if you go over to Window and then Layouts, I usually work in a tweaked version of 2x3. I usually just grab my hierarchy, the project window, and I put it under my hierarchy. I also move my game tab up with my scenes tab so I can flip between the two on the fly. But yeah, like I said, if you want to mirror your screen to mine, that's how you would do it. Okay. So let's cover the hierarchy first. The hierarchy, that's basically where everything in your scene lives. Right now, we just have a blank scene. When you open a blank scene in Unity, you're going to have the main camera and you're going to have a directional light. The directional light is basically the sun. So it's going to be your environment light. If you click in the hierarchy, right-click in the hierarchy, you get this drop-down menu with a bunch of options. If you go to 3D objects, you can put 3D, the primitive shapes into your scene. So this is how you would do that. So if we just drop a cube in there, you'll see in the scene view that we get a cube and it exists in our scene. We have these 3 arrows where we can drag it around on the X, Y, and Z axes. And just take note, the axes are also color coordinated. So you have the red axis is X, the blue axis is Z, the green axis is Y. So that'll move everything up and down. And yeah, pretty self-explanatory there. So we're going to start at the very end of that list. We're going to use a bunch of Unity primitives to build our field, to put the car and the ball and the goals into. It's going to contain all of our game logic, pretty much. So to do that, we're going to use a bunch of planes. So go ahead and select 3D object and then plane. And it's always a good practice to reset the object position to origin or just 0, 0, 0. So with the plane selected, again, you can just click on it from the scene view or click on it from the hierarchy, whatever you want to do. And then you want to go over to the inspector and look at its transform position. So you may have some weird position in there. Mine got thrown at a bunch of like -1, negative whatever. So just go ahead and plug in 0 for each one of those, and that'll reset the your primitive to origin. Whoop, sorry about that. So while we're messing on the inspector, you'll notice that this plane already has a bunch of components already attached to it. The transform is, for this tutorial, we're going to be working with that the most. A transform, it's literally just a game object's position in 3D space, its rotation, and its size or its scale. If you just play around with those, you'll see what that does. And so it'll rotate. You can move it, can scale it, and do whatever you want. Oop. Don't set your scale to 0. Things will disappear. Okay. Let's see. So let's go ahead and start organizing our scene. If we don't do this now, the hierarchy and the project window are going to get a little messy. So up in your hierarchy, go ahead and click into that and right-click and do create empty. And what that'll do is create an empty game object. The only component it has is literally a transform, nothing else. Go ahead and 0 that out. And right-click on your game object, go to rename, and we'll call this world. And if you want to, go ahead and select your main camera, your directional light, and your plane, and just drag those on top of world, and we will then child those game objects into world. So you'll see that you get a little drop down by world now, and that'll help us just keep our scene a little more organized.
Quick question.
Yeah, what's up?
If we don't have the main camera and directional light, is that an object that we could create?
Yeah. So if you don't have that, go ahead and go into your hierarchy, and for the directional light, it's light, and then directional light. And then for the camera, just right-click in the hierarchy, and you could just select camera from there. And it should just dump both of those out into the scene for you.
The default position for the camera, what's that?
So in my scene, it put the default position to 0 on X, 3 on Y, and 0 on Z. Oh, sorry, that was the directional light. The main camera. The main camera was at X0, Y1, Z -10. And you'll notice you'll get a little camera preview window in the scene view. That'll just kind of give you an idea of what the camera's looking at. If you want, you can also play the game with the play button up at the very top. There's not going to be a whole lot going on, but when it's playing, you can pause it, you can unpause it, you can what is that? Go to the next scene or end the scene. If you just click the play button again, it'll just stop playing your scene. So yeah, so let's go ahead and make this a little more exciting. So on the plane here, actually no, let's go ahead and put the car in. Okay, so from your Project tab, go to your Standard Assets folder, and inside of the Standard Assets folder, you should see another folder called Vehicles. Go ahead and open that. There should be a car directory in there, And in the car directory, there should be one more called prefabs. So open that one. You're going to see, well, you should see 3 prefabs in there. Take car and just dump it into the hierarchy. And you may have to reset the position on this car. I don't know why it put it at like Z254, but whatever. Boom, there's our car. So, is everybody with me? Does everyone have the car? Because if you don't have the car, that's a problem. All right, good. I don't see hands, so I'm going to assume we're good. So if you play this right now, the car moves with W, A, S, and D. W and S are forward and backward. A and D will steer the wheels, and if you go too far forward, you will just fall out into the abyss. So, yeah. So let's go ahead and focus on the level now. So let's keep the car out there. So that plane we created earlier, let's go ahead and scale that up a little bit to give us a little more driving space. So on the x-axis, let's stretch that out to maybe, 5 will probably do it on the x-axis. Then on the z-axis, maybe, what does 10 look like? Yeah, so that'll work for right now. So on that first plane, set the x-axis to 5 and the z-axis to 10, and that'll give us our soccer field. And really, you could use whatever dimensions you want. The key here is that we want to seal up the map, so like the ball can't fall out or the car can't fall out like we just saw. Cool. Oh, and before I get ahead of myself, if you haven't already, go ahead and save with either a file save or a Control S. It should prompt you to name your scene. So I'll just call this one. I'll just call this one field. Name it whatever you want. It doesn't really matter. So when we save the scene, it should just get dumped out into your assets folder. And again, it's always a good idea to keep your project organized. Just do this from the beginning, and it will save you a lot of heartache going forward. But we could just name this folder scenes and dump our working scene into it, and Unity will just take care of everything else for us. Okay, so let's go ahead and put some walls on our field here. So go back to your plane, select it in the hierarchy, and then do Control-D to duplicate that game object. You should now see plane parentheses 1. And what you can do here is, in the upper left-hand corner, you're going to see a rotation tool. You can rotate this 90 degrees. And then with the move tool, we can drag it over. And I think if we put it in, yeah. So if you put it at the X position of -25, that should seal up the ground and the wall. Let's go ahead and just move this up a little bit. And what am I? Oh, I'm rotated. That's weird.
How are you snapping to the grid?
Oh, so that's a good question. So to snap to the grid, as you're moving something, if you hold down Control, you'll notice that whatever game object doesn't move as smoothly. Well, I think my snap settings are a little too low. Let me change that. We'll do this 1, 1, 1. There we go. So yeah, there you go. It's a little more exaggerated. So, yeah, like I said, if you hold down Control and you move, the object will snap to the grid. That way your game object isn't like set to a XYZ position of like some floating decimal point number. You don't have to snap to the grid, but again, it helps keep you organized, and it's a little bit easier to work with. So yeah, let's go ahead and reset this to rotate that wall to 90 degrees, and let's go ahead and bring it forward and just kind of shape that up a little bit. Let's make that a lot shorter too. Let's see if we scale that down on the x-axis. Yeah, let's put it at, yeah. So after you've rotated your duplicated field, if you set the scale on the x-coordinate or the x-axis to back to 1, that should suffice for our wall. And it looks like I'm not. Oh, okay, I said -25, didn't I? There we go. So yeah, everybody good on the wall? Okay, cool. So again, that wall we just placed, do another Control-D on that. and rotate it on the y-axis 180 degrees. And then move it on your x-axis back to positive 25. And that'll get us, get the other side of that wall for us. And we just have to seal this up. So I'm going to go ahead and knock that out.
So why do you have to rotate it 180 degrees?
I will show you. Here, give me 1 second. Let me... Yeah, so exactly that. So this plane, it is a one-sided game object, and there is a component on each each of these primitives called a collider. That collider is only going to collide on that one side, so you can pass through the blank side pretty much. Also, there's a mesh renderer. It only renders that one side because it's a plane. If you turn that off, oh, that's the collider. Whoops. If you turn off the mesh renderer, you'll see that your game object becomes invisible because it's not being rendered anymore. So, and you can do that with any component on any game object. Like, it'll usually have this checkbox, and you can just enable it and disable it on the fly. Okay, so let's go ahead and seal this up. No, if most of the time, if you can't, like, if you can see through part of a game object, that means you can usually just go through it, unless you have like an invisible wall or something. So, do what?
I thought it would have been called backface colon.
That too. I don't know all the appropriate terms, but yeah, that works.
I recognize it from Blender.
Oh, well, yeah, see, there you go. I don't know a whole lot of 3D modeling myself, but yeah, same concept. Yeah, so here we go. If you play this now, the car should have enough room to drive around in. And it shouldn't fall out of the... Where am I? Whoop. Let's see if I can... Yeah, so immediately our need for like a follow cam is incredibly painfully obvious. Yeah, so I'm just like driving on a wall right there. So yeah, we have the field and we have the car. Everybody good? Because that's probably going to be one of the harder parts. All right, cool. I'm going to assume we're good. Okay, so this is where we're going to get into the scripting a little bit. Let's go ahead and create the car camera first. So there are a ton of different ways to create a follow camera. I tried to think of the simplest implementation that I could. So if you can think of a better way to implement your camera, by all means go for it. But just for the sake of this tutorial, we're going to do this a little weird. So we already have our camera in here. Oh, I didn't think about this. Go ahead and pull main camera out of the world game object, just so we can see it in the field. Okay, so with the main camera selected, let's go ahead and find a good position near the car. So we're going to hold on to that. So this is a -2, -5. Excellent. So let's go ahead and create another empty game object and move it to the same coordinates as the camera. And you can do that by, there's this nifty little trick. So if you go and you select the camera and you go to the transform, there's going to be a little gear icon. Click on that gear, and then I think it's copy, I thought you could copy component values. Is it just copy component? Oh, okay. Sorry about that. And then go to your empty game object, and then you can paste component values, and it will move our empty game object to the camera's position for us. So what we could do here is just simply parent the main camera to that empty game object, and then parent the game object to the car. That works. I was going to tackle it a little bit differently in scripting, but I mean, if you see now, the camera actually follows the car. You could also just flat out child the camera to the car, but I'm going to do something with this game object. So let's go ahead and move the camera out of that game object and rename the empty game object. Let's call it camera rig. There we go. So let's go ahead and create a follow script for this. So go to the project window, click on your assets folder, and let's create a new folder called scripts. And then in there, we are going to create a new C# script called camera controller.
You mind going back to the camera for the values of the X, Y, Z?
Yeah, so the camera rig is going to be childed to the car game object, and it's going to be at a position of X0, Y2, and Z -5. So it should be pulled out from behind the car a little bit and pulled up a little bit. So up and out.
Camera rig, the empty game object which contains the camera.
No, the camera rig, it's just going to be an empty game object that is basically just coordinates in space, effectively. The main camera, make sure that is sitting in your scene hierarchy all by itself. Like, it's not parented to anything, it's just out there.
And then you said create a new C# script.
Yeah, so if you don't already have this created already, just go ahead and create a scripts folder in your assets folder. So it's just, right-click, create, and then folder. And then once you have the scripts folder created, same thing, right-click inside that folder, go to create, and then C# script.
What did you name that one?
Camera controller. And once you have the script created, double click on it, and it should open up in whatever IDE you have configured. I'm going to ignore that. All right, so when you open up a blank script, it's always going to have two methods in there. It's going to have a start method, which is what you do to configure whatever script you're working with, and you have an update method. The update method is pretty important because it runs every frame, and it updates the game object or the game logic. Whatever you put in the update is going to run with every frame that the game is being rendered. There are also two other methods that are similar to update. You have late update, which again, it runs every frame, but it runs after the update method. So if you have some important game logic that needs to run an update, and you have to ensure that it runs first, you can put that in update, and then your whatever late update logic in late update, and it will run after that. You also have fixed update. And fixed update is a little different in that it runs at a fixed rate of, I think, 60 times a second, so 60 hertz. So it's really important to put things like anything dealing with the physics engine. Ideally, you want to put that in fixed update. And there's some important reasons behind that we're not going to get into with this lesson, but just trust me, if it's physics, fixed update. Okay, so let's go ahead and create some variables here. So we want the camera to follow the car without parenting it to the car. So let's create a public game object. I'm just going to call it cam for camera. And I'm also going to create a public game object called car. And a third public game object called camera rig. The way that I have my script configured, I'm not using the start function which is probably a bad practice, but don't worry about it. And in the update method, we're going to write a method called carcam.
Can you make the font bigger?
Oh, yeah. What is it, view?
I can use control.
Can you? Oh, yep, you can. There we go. Can everyone see that? Okay, cool. It's been a minute since I presented, so my bad.
Okay, a little bit bigger.
Yeah.
It's kind of hard to see on stream.
Is that good?
I'll let you know in about 30 seconds.
All right, so I'm just going to keep working. So let's go ahead and create our carcam function. So to get that created, it's void and then the function name. We're not using any arguments, so we're not putting anything in the parentheses.
Is it C++ or
C sharp.
C sharp?
Mm-hmm. Do I have... All right, we'll not worry about that right now. All right, so all we're going to put in this is we're going to take our camera, we're going to get its transform, and we're going to get its position, and we're going to set that equal to the camera rig's position. And it's going to do that every update. Also, for good measure, we're going to throw one more thing in here. Camera, transform. We're going to use this lookat function, and the lookat function does exactly what you think it would. You take a game object, you plug it into the function, and whatever that is attached to, it will look at whatever game object you've told it to. So we're just going to do lookat car dot transform dot position. All right, so if we save that and we go back to Unity, we go back to our main camera, and we can just drag and drop this script onto our camera. And if you notice, we have 3 fields here on the component. We have the camera, the car, and the camera rig. What you can do is take each of those game objects from the hierarchy and dump it into that component. So let's take our camera, and there's another way to reference the camera, but again, I'm just dirt simple. Take the car and just drag it into the car slot, and then the camera rig, and whoops, dump the camera rig into the camera rig slot. And if we play this, we should have a very similar result that the camera now follows the car. It's not parented to the car in any way. It's just its transform is updated to the camera rig position. Does that make sense? Everyone with me so far?
So when you drop the script onto the camera, you got the camera controller script option down there where you can define the 3 variables for the camera, the car, and the camera rig.
Mm-hmm.
I don't think I got that when I dropped mine.
Okay, so on your script, did you define those variables as public?
Yeah, public game object, cam, car, and camera rig.
Is the script saved?
I thought I saved that.
Go ahead and give it another save, because sometimes Unity doesn't update the script. And what I'm guessing happened is Unity is referencing like the original script at the start and the update function, and it doesn't see those variables yet.
I think if you click on the script, it'll show like a preview of what you made fixes in.
Oh yeah, it'll do that as well.
Yeah, I see the information that we put in.
But you're missing those 3 fields?
Yeah.
Are you selecting the script or the camera?
I'm selecting this. I selected the script and I dragged it onto the camera. Yeah. And then it creates just the camera controller. Script, not the object controller.
Oh wait, you got it first.
So I think you probably, your script has an error in it. So open it.
Oh, syntax error.
So that lookat, that should go on the cam, not the, or I'm sorry.
Oh, I see, yeah.
We good?
Okay, yeah, now.
Cool. All right, so again, if we play this, the camera will follow the car. We can do all sorts of cool stuff now. We can actually see where we're going, which is pretty valuable. So let's go ahead and throw the ball in here. So in your hierarchy, go ahead and right-click, go to Create 3D Object, and then Sphere. Let's go ahead and reset that to Origin. And let's plant it at about... set X and Z to 0, and then set Y to 5. And let's go ahead and scale this ball up a little bit. So that'll work. Let's actually move this up a little bit too. So go ahead and create a 3D game object that's a sphere. Put it at position X0, Y10, Z0, and then scale it up on to 5 on all axes. And if we were to play our scene right now, not a whole lot would happen. We just have like this floating planetoid thing right there. So to fix that, to actually hook this ball up to the Unity's physics system, select the sphere, go to Add Component, and do a search for rigid body. And go ahead and add that component to the sphere. Make sure that use gravity is checked. It should have all the right values in there by default, so you shouldn't have to mess with anything in the component. So now if we play it, you'll see that the ball falls down and starts rolling around. So there we go. We already have like half of Rocket League done. Okay, so this is all pretty boring. We can't really tell what's going on. Let's go ahead and create some materials, which will get some color in here. So in your project window, go ahead and select your assets folder again. We're going to create a new folder. We're going to call it materials. So when you have your materials folder created, go ahead and right-click inside that new directory. Go to Create Material. And you can name it whatever you want. I'm just going to call this one Green. And you should see just another sphere in that folder. What we're concerned with is something called the albedo, which is basically the primary color of this material, this texture. And all it is just a solid color. So if we drag these down and boom, there we go. We have a green, and we now have a green material. So did everyone see what I did there?
Yes.
Cool. All right. So if you take that green material, you click on it, and you literally just drag and drop it into your scene, you can throw that on anything. So now we actually have something that maybe almost kind of resembles grass, maybe. So let's go ahead and do that one more time, and we're going to make a yellow material for the ball. And again, just when you have that material created, just drag and drop it onto the ball. And now we can almost kind of see what's going on. And if we want to, we can make a material for the car, and you can make it whatever you want. I think I'll make mine, I'll just make it red. And you can kind of play around with the material with the metallic and smoothness settings. So with metallic set to 0, you're going to have an object that kind of looks plasticky. The higher you have this metallic number, the more metal your material is going to look. And the smoothness, again, just dictates how rough the material appears to be. So I'm going to set that to like 0.9 because I want like car paint. And if I dump that on the car, it almost kind of looks like a car maybe. So, okay, so we have, where's our checklist? We have our car, it moves around. We have a ball, it rolls around. The camera is following the car. What we want to do now is implement Rocket League's ball cam. So does everyone know how the ball camera functions in Rocket League?
It followed the ball instead of you. It followed the car. It still followed the car, but
Exactly. Yeah. So it does exactly that, but it also does this interesting thing that it also pivots around the car. So we have to figure out a way to implement that pivoting action. Otherwise, it just looks gross. Okay, so let's go back to our camera controller script.
Do you have a video of that? Like of the ball?
Yeah, I'm sure I do. Here, let's go to YouTube. Because I'm sure that's probably, your mental visualization probably is not all that great because I sucked at explaining that. I really wish all these videos weren't like a bajillion minutes long. Okay, so right now this guy is switching between the car cam and the ball cam. Car cam, ball cam. So yeah, let's see if I can find a better shot of that. He's switching way too fast. Here we go. So here's a good shot. So you notice the camera's always focused on the ball, but it's also pivoting around the car, so the car is always in frame. That's pretty useful. Otherwise, you're kind of you're going to get a little disoriented when you're driving, and you might not see what's around you.
So you're saying we don't need a script that pretty much say, okay, follow the car, but always point yourself to the ball.
Pretty much, yeah. And we're just going to edit our camera controller script to do that. Before we do that, let's go ahead and we're going to create a new script first. So for the sake of example, go ahead and create a new 3D object and make this a cube just so we can actually see what's going on here. Set it to 0, 0, 0. Child it to the car. And after it's childed to the car, let's actually raise it up a little bit to like, let's put its Y position to 2. I think that'll be okay. And we're gonna keep that cube there. So again, if we play it now, we should just see this cube that's always floating above the car. Yep, perfect. Okay, so back in your scripts folder, create a new script. We're going to call this one Pivoter. And it is going to do exactly as its name implies. And this one script is going to be pretty simple as well. So the 2 default methods that you get, we don't need those. We can go ahead and rip those out. And we don't need any other variables either. So what we can do is, in our late update function, we'll take the transform of whatever game object this script is attached to. We're going to use that same lookat function that we used earlier. And I can't even read my own notes. We do need a variable in here. Sorry about that, guys. We're going to reference the ball. So create a public game object ball outside of the late update function. And then inside of the lookat method, we're going to reference the ball's position. So again, that's just ball.transform.position. And the reason I'm using late update here is, long story short, I want to ensure that the car has moved first before I actually move the make this lookat function run. So. Everybody good there? Cool. All right, so back in Unity, we're going to take that pivoter script and attach it to the cube. And now if we, and we also have to feed in the, here, let's go ahead and rename this sphere. Let's go ahead and, yeah. So the script, we have a public game object that is the ball, and then we're using the late update function to update the transform to always look at the ball.
Yeah, and my code assist is like gone away, so I'm having to type in.
Oh, no, that's fine. Okay, so while you're doing that. And I'll go ahead and run this to show you what this is doing. So if we run this, you should notice that, uh-oh, it's broken, hold up. Ball, oh, whoops. Thought I already did that. All right, so after you assign the reference, it's the exact same thing we did earlier. We have that ball field in the component. All we have to do is just drag and drop the ball from the hierarchy into that field, and it should function. There we go. So it's a little hard to see right now, but that cube is always facing the ball, no matter where you are on the field. Okay. So now that we have our cube, it's always looking at the ball. Select the cube object. Let's go ahead and create an empty game object on that cube. And we're going to pull it out on the z-axis to about -5. So about the same position as the previous camera rig. And we're going to name this one ball camera rig.
So we're moving the position, just magnifying?
Yes, on the ball camera rig. So that cube that we created earlier with the pivoter script on it, you want to create an empty game object on that cube and then just pull it out to -5 on the z-axis. It should kind of look like this. So that's the position in the scene. It's pretty much on top of the camera in its default position. And this is the way it's set up in the hierarchy. So we have the car, and then childed to that car, we have the cube with the look at script on it. And then we just have that camera rig childed to the cube. So now that we have that, let's go ahead and go and update our camera controller. Let's create another function called ballCam. And let's create 2 more public game object variables called ball camera rig. Yeah. So the last 2 game variables we're going to create are the ball camera rig and then the target. And this ball camera is going to be very, very similar to the car camera function, except we're going to plug in, we want the camera to update to the ball camera rig position, and we want the camera to always look at the ball. Did I not? Whoops. Car cam, target. I forgot. My bad. It helps if you actually have the object in your script that you want to look at. So again, very similar to the car camera, we just have our main camera. Its position is always going to be updated to the ball camera rig's position, and then the camera is also always going to look at the ball's position every time we run this. So let's go ahead and remove car cam and replace it with ball cam. And if we run this, we should get a very similar.
Can you go back to the script again real quick?
Yeah. Oh, sorry. Okay. So again, if we run this in Unity, we should get a very similar ball cam effect from Rocket League, except, whoop, I forgot to assign my references again. Sorry, guys. All right, let's go back to the main camera. So we have to plug in the ball camera rig. We have to plug in the ball. And for right now, let's just say the target is the car. We're not going to worry about that yet, though. There we go. And good enough. The cube is in the way. We can fix that by just disabling its mesh renderer. But we get a very similar camera in that it will pivot around the car. You kind of almost have some kind of frame of reference, and it will always focus on the ball. Okay, so the next thing we need to do is create a way to switch between the two camera systems. Let's go ahead and create a new method. We're going to call this method switch target. So the way that we're going to do this, we're going to be checking for input from the players. So in Rocket League, I think the camera system is bound to, left click on the mouse. So we're going to do the same thing here. So we're going to be looking for input. Yeah, here we go. So we want to get the get key down method from input, and we want to plug in keycode dot mouse 0, which is left click on your mouse. And once you have that, we're going to plug in two more if statements. So if the target is equal to the car, then when we click down the mouse, we want to switch the target to the ball. So target equals ball. And if the target equals the ball, we're just going to set the target back to the car.
Can you go back down to that one for a little bit?
Yeah. And once you have that, just yell at me or wave your hand or throw me a thumbs up, and okay, I think we're good. Now to wrap this all up, we have to use all these functions. So, all right, let's go ahead and create a late update method. We're going to take ball cam, drop that down into late update. We're also going to call car cam and late update as well. And then from update, we're going to call this switch target method that we just created. So basically, the thinking here is every update, we're going to be looking for input from the user in the form of a mouse click. If we get that, we're going to switch the target to whatever that game object is, whatever target is set to at that time. Late update is going to run immediately after that, and it's going to focus on whatever the target is. Oh, we have to do some quick edits to our two camera scripts, though. I forgot. We need if statements up here. Okay, so on car cam, we're just going to have a very simple if statement. If the target equals the car, then do all the camera shenanigans. And we're going to do the same thing for the ball cam. So if the target equals the ball, do all of the ball camera shenanigans. Here we go. Is everybody good on this script? Because if you are, this is the longest script we're going to make today, and it's all downhill from here. Cool, I'm going to say we're good then. Okay, so if we go back to Unity, we save and we run this, Make sure I've got all my, all the references in there. Okay. Excellent. So we start out with the car camera, and if we do a left mouse click, we switch to the ball camera, and we can switch back and forth. There we go. So now we have like 3/4 of Rocket League done. Okay. So on this cube, go ahead and disable the mesh render if you haven't already. That way it'll just get out of the way of the camera. All right, so what we're going to do now is set up the goal areas. So those are just going to be cubes that are, they're basically going to be triggers. They're going to be looking for collisions, and if there's a collision, we're going to update our score system, which we're going to implement right after that. So for right now, let's just go ahead and get the trigger set up. So in your hierarchy, go to Create 3D Object and then Cube. And let's kind of size this up to fit into the end of our field here. So 50 on the x-axis. I think 10 actually. 10 on the y-axis. And then on the z-axis, let's do 10. There we go. So we should get this fairly large rectangle. And if we just drag that into the back corner, or the back end of this field, that will function as one of our goals. Let's go ahead and throw a new material on it as well to make it a little more visually interesting. So just make a new material called goal. We will make this one red as well. But instead of its rendering mode being opaque, we want it to be transparent. And once you've set its rendering mode to transparent, click on albedo. And then down here where you see RGBA, you want to drag the A slider down to about 128. And what that'll give us is a somewhat translucent-ish kind of material that we can see through. So on your material, make sure the rendering mode is set to transparent. I'm pretty sure alpha is still there if you have it opaque, but it doesn't work if it's opaque. So rendering mode transparent, then you go to albedo, and then you click on the little color field right here. And then below this map, where you have brightness and saturation, you have these RGB A sliders. A is the alpha, or the transparency of that material. So we're going to have to create another script here in a second to get all of the goal functionality implemented. But before we do that, we're going to create another empty game object. And let's drag that up to where the ball is currently in the scene. So 10 on the y-axis. And for the sake of clarity, we're going to rename this game object ball spawner. And that's all we have to do with that empty game object. So basically, it just sits above the field in the middle of everything. So when we score a goal, the ball ideally is going to be reset to that position, so we can just keep the game going. Okay, so once you have the ball spawner script, object in your scene, let's go ahead and create a new script. And we'll just call this one goal. And like I said, this is going to hook into Unity's trigger system. So it will only be affected whenever we score a goal, so it'll only be called that one time. So we're going to need a few variables for this. So we'll need a public game object. We need to reference that ball spawner that we just created. We need to reference the ball itself. And in a minute, we're going to reference the scoring system. But for right now, this'll do. Okay, so for the method itself, it's going to be void on trigger enter. And we have to feed this an argument. So it's going to be looking for a collider, and we're just going to call that collider other. Everybody with me so far? Cool. Okay, so when we detect a collision, we want to get the ball, and we basically just want to reset its position. So we're going to set it to the ball spawner's position. We're also going to do two other things. So when you knock the ball into a goal, that rigid body is hooked into Unity's physics system. So it has values for like forward vectors, angular rotation, all of that. So we don't want to move the ball and then have it spawn in and still have some of that momentum wherever it's going. So we want to cancel out the velocity and the angular velocity, which is where we start messing with the physics system. So to do that, we go to ball, not the ball spawner, but the ball. Yeah. You want to call get component, and this one's kind of interesting because you have to reference the component that you want. So from that, we want the rigid body, and that goes inside those two brackets there, not the parentheses. And once we have the rigid body component, we want the velocity, and we're just going to set that equal to vector 3, 0, which is just shorthand for zeroing out whatever vector you're trying to work with. We're going to do the same thing for the angular velocity. So again, get the rigid body component, and then angular velocity is equal, again, to vector 3.0. Everybody with me? Did that make sense? Cool. So in short, we score a goal. When the ball touches that red goal that we made earlier, the ball's position will be reset to the ball spawner position. And before we can test that, we have to go to our goal. Come on. And then in the box collider component on your goal, you have to check is trigger. Make sure that is checked, otherwise this will break. And let's just go ahead and add our goal script. Reference the ball spawner. Reference the ball. Save it, and let's hit play. And as long as I set all this up correctly, the ball should spawn in, and then we should be able to push it into the goal. And the ball should reset. And because we zeroed out all of the velocity it had, it just sits there. So we can knock this around and do whatever. So let's go ahead and set the goal up at the other end. So again, with the goal selected, just do Control-D. What's up?
You might go back to the script. I'm getting a script error.
Yeah, sure. Let me move that real quick. On the goal script.
Yes. There's a typo instead.
Also, I have all of the scripts up here. Like, I'm not doing this from memory. I cannot code and present at the same time. So if you want to grab a photo of these or whatever, that's fine. Also, this talk I'm recording it and I'm going to put it up on YouTube later. Yeah, if I'm going too fast, just yell at me or something, because I feel like I've lost you guys once or twice, which is my bad.
Can you put a zip of the project up?
Yeah, sure. Yeah, I'll do that. I'll just put it up on my Google Drive, and I'll put the URL out on Meetup and Facebook. Can you? Okay. Yeah, short answer, yeah, I'll make all of this stuff available to you. And if you have any questions, feel free to stop me. So, but yeah, we're almost on the last leg. All we have to do now is we're we're just going to keep count of how many times we've knocked the ball into the goal, and that's pretty much it. Okay, so again, all I've done here... Oh, sorry, that was a question. All I've done here is I got the main goal, I did a Control-D to duplicate the game object, and I just drug it over to the other side of the field. So if the ball gets knocked into either goal, it'll just reset. Okay. So now we're going to touch on Unity's UI a little bit. So go to your hierarchy, right-click, and then do Create UI, and then Text. And you won't really notice a whole lot has changed. But if you go to your game preview, you'll notice that there's like this really small text that's just kind of like floating right there. What we want to do is anchor that to the top of the screen and the middle. So to do that, with your text game object selected, you want to come over here to the rect transform area component of that text object. That works very similarly to the normal transform of a game object. You could just do some other tricks with it, like, well, I'll show you that in a second. So to get the text anchored where we want it, click on this little box right here, and hold down Control and then Alt. You should see that little box area change. What we want to do is select this top middle box right here. And you'll notice that the text is now moved its position on the screen. Let's go ahead and change its alignment to be centered. And this is where we're going to display our score. Let's go ahead and make this a little easier to read as well. So you can change the color of your text. And let's go ahead and change the font size to like 24, maybe 64. I don't know where that... Oh. So you can size the font a little bit too big and it will be cut off from the camera. To fix that, you can go to horizontal overflow, go to overflow, it was set to wrap, and then go to vertical overflow and set it to also overflow. So you can see here that we just made it too big for the screen. So we'll downsize the font to like 30. 30 works. So now if we play this, we're just going to have this text on the screen that just says score. We can't really do anything with it yet. So what we need to do is make our scoring system. And we're going to create a method in that scoring system that gets called every time the ball is moved into the goal area. Okay, so in your scripts folder, let's go ahead and create a new script. Let's call it Scorekeeper. Oh, there we go. And let's open up our Scorekeeper. So this script is going to be a little special in the fact that we need to use another namespace other than just Unity Engine. If I can type. Interesting. So the namespace we want is unityengine.ui, which gives us access to all of the user interface objects and methods. And in here, we just need two variables. So we're going to have our public integer called score, and we're going to set that to 0 because game starts, you haven't scored anything. So, and then after that, we're going to have another public game object called text, which I don't have access to for some reason. One error. What is my error? Oh, no 0. Okay. All right. It just took a second to catch up. And we're actually going to use the start method here. So when at the very first frame that our game runs, start will be called. And all we're going to do is set our text, .text, equal to score. And this part's pretty important because you start dealing with different data types. I'm not getting the error here, but I'm pretty sure it'll crash because score is an integer and text is just a string. We have to call the toString method. Okay, so we don't need update, but we do need a public function for when we score a goal. And all this is going to do is increment our score by 1. That's what score plus plus does. It's just shorthand. Do what?
I said total double speed.
And we're going to set our text equal to score again. And don't forget to include the to string. Okay, so we have our scoring system implemented. It's pretty simple. To make this actually function, we need to go back to our goal script. We need one last variable. Am I doing that right? Yeah, sorry about that. So what we just did here is we created a scorekeeper. Why is that freaking out at me? Hold up. I'm gonna close Visual Studio and restart it because sometimes it just freaks out. On this machine at least. Yeah, here we go. And now it appears to be functioning okay. So basically, whenever the this trigger event happens, we just want to call the score goal function that we made earlier. So let's go to scorekeeper dot score goal, and that should do it. Oh, whoop, I forgot to assign all my references. Derp. Sorry about that. I think I forgot to attach the script on that too. Oh, yeah, I forgot to do one thing. I'm going to create an empty game object, and it's just going to hold our scoring system. There we go. And from here, all we have to plug in is that text game object that we created earlier, and now it should work. Oh, wait, hold up. There's one more thing I forgot to change. Yeah, that scorekeeper that I made earlier. Let's go ahead and drag scoring system into that, and that should have taken care of that on... Yeah, there we go. All right, third time's a charm. Now it should work. So now, when we play the game, you'll see that score is changed to 0. If we push the ball into this goal, we increment our score, the ball resets, and if we keep going, we should be able to count that up eventually. Yeah, there we go. So yeah, we have a scoring system, we have a car, it has 2 different cameras. Yeah, we kind of almost prototyped Rocket League, and that only took about a little over an hour. So, yeah, does anyone have any questions or anything? Any feedback? Because this is the first presentation I've done on an Intro to course in a while.
With the camera controller,
Mm-hmm.
would it be possible, instead of having the 2 car cam and ball cam methods, to just have a single cam method that calls the target and the target's camera rig?
Yeah, like there are definitely ways to optimize all of this. I basically tried to take one implementation and do it over and over again, just to hammer it into you guys' head. So yeah. But yeah, that's pretty much all I got. Like I mentioned earlier, we're gonna have a game jam, not this weekend, but next weekend. It starts on April 20th, and it's gonna go all the way into Sunday, so from Friday to Sunday. And it's basically a weekend of just, us heads down working on a game like this. So if that's something you think you'd be interested in, it's just going to be here in this room. It's free. I think we're gonna set up like a meetup page or a Facebook event. We do ask that you RSVP for that, just so we can get an idea of head count. But yeah, that's pretty much all I got.
You will have food and drinks and prizes, maybe?
Maybe. I thought we were still hashing out those details.
That's why it's made.
Let's make it happen.
Yeah. Okay. Yeah, we'll see. So
What happens if you drive your car into the goal?
nothing. You'll just go through it.
Actually, I
So
think
is
the
it-
ball's gonna reset.
I mean, yeah, the ball will reset, but the car won't do anything.
Yeah, I think your score will go up.
Is this one gonna be like the last
Oops.
game jam? Is it gonna be?
Whoops. Hold up. I think I left something out.
What? They actually said.
Whoops. Yeah, so that's my fault. I missed something. I have an if statement in my goal that checks to make sure that what's colliding is actually the ball. So, sorry, I missed a detail. But no, I will make this project available to you guys. This was recorded. I'll make that available. Before you head out, if you are interested in, learning more about Unity or more about game dev, Unity has a ton of great resources. They're way more comprehensive than everything I just went over. I tried to just do a brief overview. They're also a little more concise. I kind of rambled on a little bit, so that's my bad. But yeah, we have Rollerball is what we typically do. I thought Rocket League might be a little more interesting. They have the survival shooter, which is basically kind of like a horde mode shooter. They provide all these pre-made assets, and it's like a wave shooter, like a horde mode or like COD Zombies or something like that. There's a tanks tutorial, which is local multiplayer, and then they also provide a networked multiplayer version of that. Their adventure tutorial covers things like data persistence, so like saving games and like saving the state of your game, things like that. So if you're interested in that, just go to unity.3d.com/learn/tutorials. Tons of great info up there. I think there's one other thing I forgot to mention, but I don't remember what it is, so probably isn't important. So, but yeah, no, thank you everybody for coming out. Hopefully this wasn't too boring, and hopefully you learned something. So, and like I said, again, next weekend, Game Jam. Show up if you want to. If not, don't worry about it.
You say after next week.
The 20th, yes.
Okay.
Again, in this room.
Not this weekend, next.
Yes.
And is it gonna be like the last one where it's gonna be, people break up and it's like multiple games, or are we gonna concentrate on one game?
It's whatever we want to do. The only reason we did multiple games last time is because we had a pretty decent turnout. We've done game jams where it's just kind of been like 4 or 5 of us and we work on one game. It really just depends on the turnout and what people are interested in doing. So,
Feel free to invite non-game
So-
yeah.
2.5 people was a little bit much.
Yeah, like you don't need any experience if you just want to show up and try and learn, and like they're definitely marathon events. Like when Sunday rolls around, you will be exhausted, but hopefully you'll have learned some stuff.
So do you
Start
say
time is, what time on Friday? Is that?
I believe 6.
6?
okay? Do you guys stay in the building?
No. We actually get kicked out at 11.
Okay.
We can't stay here. We did have one game jam that we hosted at our co-work space on Union. I think we had 1 or 2 members that camped out, but no, we encourage you to go home and get sleep. Like, sleep is important.
You can also do it remotely.
Yeah,